Welcome everyone. Good morning. Welcome to the workshop on developing IoT applications using artificial intelligence, machine learning. Basically, this workshop is to give some kind of a big picture view to all of you so that you can start your journey in becoming AI engineer for IoT analytics. Before starting the workshop, I would like to give the background about RACE, background about REVA University, what we do here, why you must be interested in connecting with us and collaborate with us for knowing more, doing more, and becoming better. REVA Academy for Corporate Excellence is the industry arm or the kind of a quasi-industry arm of REVA University. Basically, we are into training, enabling, capacity building the working professionals in emerging technologies, whether it can be quantum computing, it can be artificial intelligence, it can be IoT analytics, it can be fintech analytics, it can be cybersecurity. So in all these emerging areas, RACE has the capability from the industry mentors to train the people, to give them the skill and skill them up and bring them to the foray so that they can start working from day one. So REVA has got multiple programs, and part of the RACE, we have got multiple programs, both short term as well as long term. What is interesting is in the long term, we have Master of Science and we have Master of Technology in Artificial Intelligence, Business Analytics, in Cybersecurity, in Data Science, in multiple areas. When it comes to short term, which is of more interest to a lot of people, we have these short-term programs in IoT analytics, supply chain analytics, and fintech analytics. So if any of you are interested, certainly we would like to connect with you, and whatever that is possible from our side, we would like to extend that support to all of you. Please feel free at the end of the workshop to connect with us and see how we can empower you to accept the challenge of the future and be prepared now itself. With this, without much ado, I would like to start the workshop. To understand what exactly we do in this workshop, it is necessary for us to understand where we are going. What exactly is Industry 4.0, Industry 5.0, where it is going, and what skill sets are required from the AI perspective, because we are niche players. We would like to bring the emerging technologies because the IoT itself is around 60 years old. It is not new, though it was more or less called as DAS, DCS, SCADA, and things like that. Now, because of the internet and connected factories, it has become more prominent. But it helps only in collecting the data. Who will give how to control it? Who will have the knowledge of that? Is that experience driven? Is that data driven? That we would like to understand, and subsequently we will move to a specific application. In fact, normally I suggest if you really want to get into analytics, implement a couple of papers and try to do that in real time and get a mentor and start doing it. And within 4 papers, you know you can solve any problem. So the agenda for today is basically to understand what is Industry 4.0. Where are we going? What is IoT and AI? Why these two has to be combined? The marriage of IoT and AI, what's the benefit? We would like to understand that. I would like to keep this discussion very short. We would like to get on to hands-on as quickly as possible. Then in the journey, I would like to talk about how do we build AI/ML models? Because at the end of the day, there are 2 ways in which we can bring intelligence and smartness to the systems. Humans are smart, no doubt. He may not be educated, he may not be trained, he may not have a PhD, but still he is intelligent. He knows what is a danger, what is not. He knows what to do when. So such kind of smartness, it's not just intelligence, not gathering the data, but the smartness, how do we bring that? That can be done through experience, codify the experience, put it to the system, or that can be done by observing the data and trying to build some kind of model of the world in which the controls have happened. So these are the 2 approaches. Both approaches are correct and both approaches are complementary. So anybody who is getting to IoT analytics should be comfortable with both. They cannot say, I will work only with neural networks. That's not the way. So we must know everything. We would like to discuss about that. Then we would like to develop an app based on the model that we have built. The model can be used for sensing, monitoring, prediction, and escalating something. And that escalation or prediction has to be shown to somebody through web interface. Actually, that is where the tire hit the road. Nobody sees your machine learning model. Nobody sees the sensor. Nobody sees anything. But what they see is what is happening with my data, how my data looks like, what is the control that you applied, is it going up, is it going down, is it dangerous, can I do something? This can be seen, and that is appreciated. If you want to get into such kind of things, this workshop is good for you, right? At any point of time, if you have any doubts, please share that in the chat. Our assistants, technical assistants are there. So they will take that up, and we will try to solve them as much as possible. But mostly we would like to keep this workshop for go long workshop. If I'm fast, please feel free to tell me I'm fast. If I'm slow, tell me I'm slow, so that I can speed it up. So that at the end of this workshop, you should have built an application using web technologies, using AI/ML for IoT. So that is the agenda for this workshop. Now let me start with what exactly is Industry 4.0. What's that we are doing? What's that we are talking about? Industry 4.0, Industry 5.0, things like that. What's the terminology? It's big one. In fact, it's given by McKinsey, which is really good. Now, if you look at it, anything from the process, utilizing the assets, labor, handling HR and things like that, inventory, that we would like to take the raw material to the finished goods. We will take the silica and then try to give a chip to control the car and the quality of the chip itself. Now, currently, the quality is maintained at 80 to 95%. Can it be improved to 100%? Nothing is wasted, right? Then supply demand match. How do I know? How do I sense what is happening? Time to market. You want to develop a new product, but you're taking about 3 years. Can you reduce it to 3 months? And service and after sales. How do you make sure that your service force, after sales force is placed so that there is no problem in the system? In fact, something like Japanese cars, 5 years, they will run without any problem unless we intentionally make something. Can we give such kind of things to the industry, to the customers, to the consumers? At the end, all of this is driven by value drivers. What is that we had to do using the smartness, the IoT, the AI and things like that? What is that we are going to do? So if we look at it, it can be energy consumption. Now we can see because of the war, the energy prices in US and Europe is hitting rooftop. India is not immune to that. India, we are also facing that energy problem. Though we say that we have too much of energy, it is not available to the end users, to the consumers at 1 rupee per unit. So we are asking why. So smart energy consumption is the way. For the same 100 rupees, is there a possibility I utilize all the 100 rupee at much cheaper rate? Can I use it better? Intelligent IoT, which is the topic which we are discussing today. Can I sense something? Can I try to predict something? And possibly, we would like to I'm telling, we are not doing that, but subsequently we would like to do that. Can I control the system itself, which is called as the digital twin? Then real-time optimization. Can I improve the yield, the quality of my output, my manufacturing output? It can be anything. Manufacturing can be anything. It can be idli batter to pharmaceutical ingredients. It can be anything. Can I improve it better? So with all these things, if you would like to see what is the common factor, the common factor is IoT and AI. What is IoT? IoT is sort of basically connecting most of the things. Basically, it is Internet of Things. What are we trying to do here? We can see everything. It can be airport, it can be shop, it can be stations, it can be homes, it can be mobile devices, any edge devices like car and things like that. Anything you name it, whether it is data center or the cities, smart cities, enabled factories, anything, they are all connected with what we call as sensors. Sensors measure few physical properties, chemical properties, and some kind of derived properties. They will try to sense it. They will try to monitor or measure that. Once we get those measurements, it has to be stored at some place, which is called as a historian. And from historian, we will take the data. Most of the time when we do IoT analytics, I may not be touching the sensor. I'll be touching the data source, which is called as the historian. So I will access the historian because AI in real time is meaningless. You cannot do anything in real time when you don't know what to do. So for that, you have to learn from historic data. If somebody says that I can give without any data, without any experience, I will do something, actually it is not correct. That you can do without his help also. So anything that you have done in the past, which gave you a favorable odds, is what we are looking at. How do we get that? We get the data from the historian and we try to analyze it. That's what we are going to do today. We assume that there is a historian, we pull the data. We build a model. Then we try to present the model to the end users. We will see this. So IoT gets the data from multiple systems at the same time. There is every possibility, if it's a distributed control system and things like that, it can even control the components. If I want to switch off the fridge from my mobile phone, it is IoT enabled refrigerator. If I want to water my plants in my home when I am out, I can control that through my mobile. That is IoT enabled water sprinkling. It can control, it can sense, it can monitor. So sense, monitor, and control are the three things that are expected from an IoT device or an IoT system. Everything is okay. You can sense it, you can measure the measurements, you can monitor over a period of time what is happening, what is not. If the preset values are there, you can control the system. IoT does the job. But the question now is, who will give that control knowledge? Where does that control knowledge comes from? Where that prediction comes from? And that comes from what we call as artificial intelligence. Artificial intelligence can be as simple as build a linear model. It can be as complex as build a deep learning model. Don't worry about all those technical details. What is needed is a rough cut 10% system which is working is better than a theoretical 100% accurate system. Being an AI engineers of the future, don't worry about building theoretically correct system. Practically wrong system, but it is useful. 60% is much better than theoretically correct system which is not there. The idea for us today is to build a correct system which can be shown to the end user. When it comes to artificial intelligence is a misnomer. Basically, really, I don't know. After 25 years, still I feel I'm in NAPIS. What to call artificial intelligence? What is intelligence? For us, more or less, we wanted to be very practical. Artificial intelligence is mimicking humans. Can I mimic humans? That is the question we wanted to answer. There are two possibilities. Try to get all the knowledge that the human has for a particular job and codify that knowledge and try to use that knowledge with IoT. That is one possibility. The second possibility is they do not want to give it, or the knowledge is so implicit that you cannot explain. How do you get something which cannot be explained? We cannot take out something which cannot be explained, but we can recreate the scenario and try to approximate that, and that is what we call as machine learning. Machine learning is not really how humans think, whether it is neural networks or anything. It is not how humans think, but the results are same, and that is called as the Turing test, right? In the Turing test, when the result coming out of the machine and the humans cannot be differentiated, the machine has passed the Turing test and it can be called as human. And that's why we call that as artificial intelligence. It contains multiple paradoxes. The first of this is neural networks, which is very popular, right? Neural networks are really good ones when it comes to performance and when it comes to the breakthroughs that are happening. Neural networks are really good. Then there is machine learning, which is what we are trying to implement today, right? We implement neural networks also. We'll implement the machine learning also. And there is a knowledge-based system. Both neural networks and machine learning are data-driven systems. Knowledge is the experience-based system. And somebody can tell if the blood sugar level is more than 110, it is most likely diabetes, is the knowledge which is already there with the doctor, and the measurement can be done with a glucometer I can take these two and combine, and now I can tell whether this person is a diabetic or not. In the same way, I can put it into machine learning. I can say I can measure all those things. I don't tell at what point it will be diabetic. I will gather all the data and just label them as diabetic, non-diabetic, and allow the machine to learn. Machine may commit anything between 90 to 110 is pre-diabetic, less than 90 is non-diabetic, and more than 110 is diabetic. It has learned on its own without any kind of knowledge, experience that will be given to the machine learning. These are the two approaches, the knowledge-based approach and the machine learning approach are the two approaches which are available for us. This is the first approach. This is the second approach. Now, the artificial general intelligence, which is the next wave that is coming in next 5 years, maybe 10 years, is combination of these two. All others are part of AI, but mostly we are looking at the knowledge-based work, data-based work. These are the two things that we are interested. So now we know what exactly IoT is. IoT is a kind of system of sensors and controllers and some kind of data storage where there is a possibility for us to sense, monitor, and control something. That something can be as simple as a thermostat for cooling and heating the room, or it can be as complex as a space shuttle. All of that is IoT. Artificial intelligence is basically mimicking the human intelligence either by encoding the knowledge which is explicitly given by the humans, like if XYZ then Z kind of rules, or possibly collecting the data and learning from that data what may be or what likely to be the knowledge that human possesses. So these two will form artificial intelligence. So once we know IoT and artificial intelligence, normally the way that goes up in the hierarchy is, can we marry these two? Can we connect AI with IoT? And that's what happens. When we connect IoT and AI, we'll be sensing something. Basically, we are measuring, for example, in our case, we are trying to measure the temperature, pressure, humidity, and vacuum. And we are measuring what is the energy that is given at the output. And if I know the first 4 parameters, can I predict the next parameter? That exactly is what we are trying to do here. Sense, measure the parameters here from the system and use it for building the model and scoring the data and predicting something or classifying something. Then based on if the temperature is high, increase the flow or increase the speed of the fan or of the motor to make it more cooler is the signal that is sent to the actuators, which is nothing but the control signal. This whole closed loop system with monitoring by humans is what we call as AI enabled IoT systems. This exactly, in fact, we may be building a 5% of this system, not exactly even 50%. A 5% of this system is what we are trying to build. We are not making it real time. We are not connecting to historian. We are not really controlling. If we want to do that, certainly we should engage more and more, and we should start doing that. We will see how it can be done at the end. But you're starting now. To do anything, beginning is the biggest problem. Once you begin, things will fall smoothly. So that's what you have to expect. So now with this introduction of what IoT is, what AI is, now let us move towards what we do in this workshop. Mostly we'll be doing for this intelligent IoT, though we can do for predictive maintenance, real-time supply chain, digital quality, advanced process control. All of this is what we are interested in. It can be done in IoT analytics, but in this workshop, we'll be working only on this. Now let's get on to AI/ML modeling. I will just go through how exactly we should start. Then we will get on to the hands-on. We'll come back here again. AI/ML modeling basically is take some data, build some model, basically try to learn some kind of relationship between output and input. Given this input, can you predict the output? This exactly is what we would like to do in AI modeling. What is the technical architecture that we are trying to use? In fact, if you look at it, it is gigantic, huge, very complex. You need not have to worry about any of that. So if you look at what exactly we are trying to do, there are data sources. Basically, these are the sensors. There is some kind of data integration. It can be Kafka if you are using big data, or it can be Kettle if you are using smaller ones, or it can be APIs like the historians. It can be any of them. Data will be integrated, and data will be stored at some place, because the past data may be used to analyze and detect the patterns which will predict the future. For that, we are using some other technology. After this, we are looking at the data analytics, where we can build the models using Python, R, Spark, SparkML, H2O, blah, 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 plenty. You can learn all of this. In fact, my suggestion is try to be comfortable with at least one of this and one of this, right? More than one is always good, but at least Python based modeling, Spark based modeling are the two modeling techniques, or the two analytical capabilities, skills you have to upgrade yourself. So once you do this, this model is good. Only you understand what the model is. But what the problem we are trying to solve? We are trying to solve multiple problems. Probably I would like to look at a retail shop, and who are all the people who are coming there, where they are spending time, how much time they are spending, how much they are purchasing. I would like to do the footfall analysis. That may be one use case through cameras. Camera is also IoT. Don't underestimate the cameras, right? Power prediction. I would like to predict, if I know the atmospheric temperature, if I know the vacuum in the suction pipe, and if I know what is the relative humidity, what is the pressure, can I predict what is the power that is produced? That is another use case for IoT, right? And how much time somebody is spending in some area, can I do that dwell time analysis? Is another use case, right? Can you diagnose fault in real time? Is another use case. There are plenty of use cases which are presented to the end user using some of these models built using these technologies, from the data stored here, from the data collected from here, through these things. This is the full stack which we want you to master. It is not that this, I know how to build the models is good, but that is not what we are interested in. Can you become specialist? We call this as full stack IoT analytics or industrial data scientist. Can you have the full stack capabilities is what is expected. What do we do today? We are going to do something with Python, something for power prediction. The application development, model development. We'll focus on these two in this workshop. What is the approach? Yeah, we will develop the model. What is a model and things like that. When you do it, you will understand that better. Listening is good, but why you have to listen, why you have to tell this is, I must condition you that this is what we are going to do. I should set an expectation for you. Expect this. This is what you do. At the end of the day, did you get this? Because I'm setting the expectation, I'm doing it. Then you can compare. Did we set the expectation? Did we get what is expected? How comfortable are you now? For that, we need an approach. The approach that we are using is called as CRISP-DM. Anything for us should go through this process. Otherwise, you'll be doing in some particular area and you are a part of the whole system. You are not this system. We wanted to make you this system so that they cannot dispense you. When you become indispensable, you're valued. Try for that. That's very, very important. Now, what is this CRISP-DM framework? How it works? First thing for solving any problem is to understand that business. That business can be putting a nappy to a child, or that business can be controlling a power plant. Any of that is business understanding. A lot of people come and tell, I can do that. The question is, you can do anything. Have you done that? If you have done that, you can talk business. If you cannot, if you are not done, you cannot. So the first thing is understand the business. You need not have to understand the business fully like a business person, but 5% of what business knows is more important than not knowing. We will get that to a point and we will see how you can understand the business. Next, okay, you understood the business, you collected some data. The next thing is, have you understood the data? When you don't understand the data, any model is okay. Understanding the data is very, very important. After you understand the data, you have to prepare the data. Raw data that comes to us is not sufficient in modeling. It's not in the modeling format. What we need in modeling format is a table. So in such cases, what we are looking at is there a possibility to prepare? Is there need for preparation of the data? In this case, we are not. because we are trying to build, as I told you, maybe 5% of what is expected, not full, but it gives you the complete end-to-end skill set that is required for building a model and application. Whether the model is competitive, can it be world class? No, that is not the intention. Can you build a model? If you can build a model, you're in the top 25% of the people who know about IoT analytics. That is the intention. It is not to make you the best. The make you best is something else that we will see later, right? After preparing the data, we would like to get into modeling. We will build actual model. All the hype that we have created about AI/ML is part of this. Then model you have built, but how good is the model? Somebody says that I got first rank. How many people were there? Only one. You cannot call it as a first class, right, or first rank. So modeling has done, but it has to be evaluated. So how do you evaluate it is another thing that we discuss here, right? I will not get into too many metrics. How do we evaluate? In fact, evaluation of a student is very easy. Write the exam, score the marks. If it is more than 35, year pass. If it is more than 50, year pass, right? Evaluation is there. So how do we get this evaluation? How do we do this evaluation? All this will be part of AI/ML. So once we do AI/ML with the data, we have to deploy that, and that is the IoT application. So we are combining AI/ML model with application or deployment, and that is a full cycle. Now, once you deploy the current model, they will come and say, oh, it is not scoring in real time. Yeah, it becomes a cycle. Oh, it is not taking multiple variables. It becomes a cycle. Oh, it is not good. It becomes a cycle. I want this to be white. It becomes a cycle. So it is a cyclic process. It is not like a waterfall like other software engineering development processes. We mostly use what is called as the agile process, or possibly the feature development with cycle. This exactly is what we are going to do in this workshop. This is the whole purpose. Okay. So once we know this, we would like to do this individually. How we do this? We would like to understand the business. Most of the time, business understanding is not coding, is not data collection, is not touching the system. Probably it is touching the system to listen to something or to hear from somebody who knows that business. The problem that we are trying to solve is called as combined cycle power plant. So the problem here is, I know a couple of variables and I know what is the electricity that is generated. Now, given these parameters, can you predict this well in advance? How good are you in predicting this? So now, what is this power plant? Basically, a combined cycle power plant is a kind of power plant which has got two stages. Normally, in any power plant, what happens is there will be a steam generator, and the steam generator will be pushed. The steam will be given to a steam turbine. Steam turbine rotates, and that rotation will cause some kind of power generation in the motor, the alternators. So generator will generate the power by the steam turbine. In general, just power plant, steam power plant. But the conversion of the heat in ordinary steam power plant is hardly about 30%. 70% of the energy that will be fed to the power plant is not used at all for generating the power. What do we do then? What we try to do is recover the heat that is coming out of it and heat the steam again and reduce the amount of input that is required to heat the steam. And that is called as combined cycle power plant. So normally we try to do it in 3 layers. The first level, some of the generator will generate the electricity. Then I try to take out the heat, and again the steam is generated here. The steam is already coming here, combustion happens, or it can be done in other ways. Now the steam generation happens here, and it will be pushed to the steam turbine. Most of the time this will be a gas turbine and this will be a steam turbine. So I have 2 turbines, one run by gas, another run by steam, and the steam is heated by the heat loss that is available, or the hot exhaust that is coming out of this turbine. 30% of this power is given here to the generator. 70% of heat is available. Out of that, another 20 to 30% of heat will be recovered, and a steam turbine is running. And this steam turbine again generates electricity. This is the whole process. So combined cycle power plant is assured to give 40 to 60% conversion of energy. So if this is the case, I know I am putting sensors in some places. I would like to measure the physical quantities like what is the temperature and what is the pressure, what is the velocity, right? All those things. What is the vacuum? All those things. Vacuum is nothing but pressure, right? Negative pressure is vacuum. So I would like to measure at different points. Once I measure those points, I will measure how much electricity generated also. Now, if I have all this data, is there a possibility using only these inputs, can you predict the output? Yes, it can be done. Is it 100% accurate? No, it is not 100% accurate. It is approximate. So if it is approximate, how good are you? I will just say average. So my average production is 440 kilowatt. How good are you? How near you are you towards the actual power produced? We would like to compute that. Our model should predict, and actually I know what is the value that is expected. If the difference between these two values is not high, my model achieved its purpose. Our task is to build that model. What we do now, we would like to understand the data. Normally, we will take the data. I will show the data later. In fact, it has been shared with you, right? It contains atmospheric temperature. It contains the vacuum. It contains atmospheric pressure. It contains relative humidity. It contains power produced and period. Time 1, time 2, it is hourly aggregate, average of the hour. So every hour it has been measured and it is been given. About 9,000 plus records have been given to us, right? These are called as the input variables. AT, VC, AP, and AH. The atmospheric temperature, the vacuum, the atmospheric pressure, the relative humidity are called as the input variables or attributes. This is called as the output variable or dependent variable or label. So using these 4 variables, can you predict this value? This is an identifier, right? This has no meaning other than identifying that record number, at what time this was measured. So we understand this data. Once we understand the data, we would like to see how the data looks like, what type of data it is. All of them are float data. The period, hour 1, hour 2, hour 3, all of that is an integer. This is another type of data understanding. We'll move on to the next data understanding. We would like to understand what are the statistical properties of the data. How many records are there? 9,568 records are there, right? We don't take mean and other things for this. I just count it, right? Next, when it comes to 80, I'm looking at what is the average. Average temperature is 19 degrees. Average vacuum is 54 pascals. Average pressure is 10-13 pascals, right? Average relative humidity is 73%. And power produced is around, average power produced is around 454 megawatts. Now, using this, is there a possibility I can predict something? For example, directly I can take, if the average temperature is known, divide this by this, right? Hardly about force of what, 450 divided by 20, I may get something around 22.5. Take temperature, multiply it with 10 to 2.5, that will be the power. It's simplest model, right? Common sense model. I can use that model and predict the power. How good I am? How good I am in predicting it? Because it may go up by 17%, plus or minus 3 sigma. If you look at it, I'm telling if it is 19, 20, let's say mean temperature is 19 and it may be around 20 into 22.5, it is 450. There is a possibility it can be, even if I take 1 sigma, it will be around 430 or it can be around 470. I'm not accurate. My range is 470 minus 430. 40 megawatts difference is there. 1 megawatt is about 13 lakhs, right? So that much of loss is what I'm going through. So if such is the case, is there a possibility I will reduce this error? If the range can be reduced, if it can be as near to the actual as possible, that is all what we are looking at. Next, we would like to look at how to explore this data. We will do all this hands-on, right? But before that, you should understand what you should expect, what you should do. In fact, I always ask a question. I don't ask question why. The first question I ask is what? Then question is why we are doing it. The last question is how do we do it? So always you ask these questions. What am I doing? Why I am doing this? How am I doing this? We'll get into this. We are answering what question now? Why we will discuss and how we will discuss. Sorry. Now my power looks like this. In fact, some of you, if you can remember your high school maths, right? Everything is called as a distribution. The frequency or the count is mapped against the value. How many 430 megawatt is there? How many 440 megawatt are there? How many 450 are there? How many 490 megawatt hours are there? So if you look at it, it looks like bimodal distribution. This is called as a mode. The peak value, right? How many peak values are there? And there are two peak values or the modes. So it means that high temperature is less or high power generated is less, low power generated is more. More number of times power generated is there. The higher power generation is less. Now, is there a possibility this can be connected with something else? And this is called as the histogram. We will work on histogram, generating the histogram. But histogram is not good. Most of the time, it will not give us a good picture. We try to go for what are called as density plots. The atmospheric temperature looks like this. It is bimodal. That is interesting. Anything that contains modes, anything that contains gaps, anything that is skewed is interesting in AI. Something like this, which is normal distribution, which is a bell curve, is not interested. All of us are 5.4 to 5.6 people. Average is 5.5. Are you at A with somebody who is 6.9? He's skewed. Are you A'd by somebody who is 3.2? You're A'd, right? Though we don't say that they are not good, they are tall and all those things. It's a wrong way, right? We feel, okay, they are different from us. They are anomalies. They are outliers. They are interesting. Normal distribution is not so interesting. So if you look at it, this atmospheric pressure is a normal distribution. The relative humidity is a normal distribution. You cannot say, is it really normal distribution? Can it follow all the rules of normal? No, it is not. Approximately, it is normal distribution. Don't try to become perfect. If you are perfect, it's a gone case. There is no perfection in IoT and AI. We are all approximate, right? This is approximately normal distribution. Similarly, if you look at vacuum, it is bimodal, though it looks trimodal, but more for all practical purposes, it is bimodal. There is one mode here, there is another mode here. So these two modes, you must get an idea. There are two modes here. There are two modes here. Are they connected? Can you see this? There are two modes here. There are two modes here. It means that whenever the temperature is low, the power production is high. Whenever the temperature is high, the power production is low. Our power production is high, right? When the temperature is low, the power production is high. Is there a possibility? Is my understanding correct? And that is what we call as verification. We want to verify what we are finding here. Is it remotely connected? Not necessary that it should be connected. You talk to a power plant guy, you talk to an electrical engineer, they say this guy is rubbish. He don't know. I don't know anything. I'm trying to learn that from data. We are trying to learn this from data. So when we see this, this is what we are looking at. Sorry. Now, once we do the exploration, we would like to look at, are the data correlated? In fact, if you see this, these are all called as univariate analysis. One variable analyzed at a time. Then we will get into what is called as a bivariate analysis. How much atmospheric temperature is connected with power? Yes, our intuition that it is negatively correlated is correct. It is 0.95. It almost determines everything. Vacuum is 0.87. Atmospheric pressure 0.52 mildly. Relative humidity 0.39. There is nothing much. So if you look at it, these two strongly correlate with what we have. And these are the variables which will be used for building the model. But in our case, we will use all the 4 variables to build the model, because model building, fine tuning, hyperparameter tuning, and trying to make it really business useful. All those things is a topic of large, long duration discussions. We will have that later. But for the time being, you assume that these two are very important. This is mildly, this is least important. So once we do this exploration, we would like to see whatever we saw here, is it really correct, right? For everywhere, yes, it is correct everywhere, right? But in some cases, outlier cases, even though the atmospheric temperature is low, the power is low, right? Power is supposed to be high, but actually it is not, right? So these are outliers. So we have to remove the outliers. In this case, we don't do, but subsequently when we get into real life application development and all, we really treat the outliers. We would like to understand why there is an outlier. So this is what we call as data preparation, data exploration. Explore the data and prepare the data. Either you drop this or try to give a reason why it is so. So once we do this, we would like to test for humidity against output. There is no relation. Actually, it is not looking like a line, right? Similarly, if I look at atmospheric pressure, it looks like some dragon, some horse, something like that, but it is not looking like a line, right? Now let us look at the vacuum. More or less, it has a good pattern. Around 0.8 is what the correlation is. And we do this exploration. Once we do this exploration, we would like to look at what is the average. The average is about 450, right? We saw that here, right? The average power is 454. If I take this 454 and assume anytime you do anything, the power generated by 454, the error is about 17. So can you see this? The error is about 17, right? The error is about 17. That's correct. Actually, this error is about 17, which is actually correct, right? Now we will see this in code also. How do we get this, right? Now I can assume the power generated is 454 irrespective of any temperature and pressure. That becomes the baseline model. With the baseline model, we would like to build different models. And this is what we get. If you want to see all of that once, right, you can see clearly that this is important, this is important, other things are not important, may not be so important, right? Okay, my apologies, sorry. Okay, so now we would like to get into modeling. So when it comes to modeling, there are multiple ways of modeling. There is linear relationship between the variables, there is non-linear relationship between variables, and we would like to build a model for both the types. The type of models that we are building are called as regression models. Regression models will go with the error, right? It is not the classification accuracy like you differentiate between cat and dog using deep learning, but this basically is how much you are far away from your expectation. The expectation was 454. You are 17 megawatts away from the actual value. So can we reduce that? So that exactly are the models that we are trying to build. The way we try to build the model is very complex. I do not want to look into all these things. In fact, we would like to take the data. We would like to cleanse the data. Some of the sensors may not be giving any value. I have to impute it, right? Then data may be available at second level, but I want average for 1 hour. I would like to aggregate the data. I cannot take all the data. I would like to take only hourly sample. I do not want all the features. I would like to select only few features. Like I showed you, I want to take only 2 features, right? Then we will get the training data. We would like to partition that into training data and testing data. Then build the model, right? Create the model with the training data, validate the model with the validation data, and this model is available for us. Once this model is available for us, we would like to look at there are 3 types of models that we are building. One is called as the linear regression. Another is called as the random forest model. The third model is called as the neural network model. We build the 3 models and we try to find what is the baseline value, what is the prediction value from the linear regression, what is the prediction value from random forest, what is the prediction value from the neural network. So we will try to get this. Now, if you look at this, then we will try to find the error. The baseline error on an average is 14.8. Logistic regression model is 3.6. 3.6%. These are at that side. Random forest model is 3.1% or 3.2%, which is simpler than or much better than LR model. The neural network model is 5.2, is worse than the linear regression. In this case, we are selecting the RF model. This RF model is used to score the data in real time, right? So we will score that, and that score data is available for the application. Then we will build an IoT application. The IoT application that we are building is based on a library called as Dash. So it uses it's a full stack framework where you need not have to know HTML, CSS, JavaScript, React. None of that you should know. You should know Python, right? You can build with minimum Python if you know how to write Python code, and if you know C, you can build this, right? It is not a big problem. That's one of the reason I told professors that they have learned C in their first year, so they must be comfortable with the programming that we are trying to build. Though it looks complex, don't worry about it. Okay, so we will simplify that as much as possible. What we are trying to do, all of this, the Flask web server, Plotly graph server, React.js to handle the data and all those things, Dash for routing and all those things, the user dashboard, all these are hidden from us. We are not touching any of them. We just call Dash application app.run, done. Things will start. So our job is mostly to develop the model and deliver that using user app. What is this user app? How it looks like? My user app looks like this. I will take what is the average temperature, what is the average relative humidity, average vacuum, average atmospheric pressure, right? Once I get these things as dial gauges, I would like to see what is the trend of them, how they are trending. I will get the trend charts. So once that is done, I would like to plot the actual value, which is blue, with the predicted value using our model. Now we can see more or less it is same, but there is a gap. Our job is to improve that gap, reduce that gap, right? So improve the model performance and things like that. That is not the topic for today. The topic for the today is build a model, deliver this, so that the second round, you will try to increase the interactivity with this app, make this real time, make the model more performant. All those things will come in 2, 3, 4 cycles. In the 5th cycles, it is ready for the users to use it. So normally we try to do this in 15-day cycles. After maybe around 5th week or 5 cycles, right? Maybe about 6 weeks or 10 weeks, the application is ready. It can go and hit the floor. This is what we would like to do. In fact, we are doing 2 hours of that first 15 days. That's the whole thing that we are trying to do. Okay. Now, if you look at this, what are the components that we would like to use in this application? The first of the component that we would like to use is called as a navbar. We will touch upon all this. We will do this with application in Dash. We will see that how it is working and things like that, right? A navbar is nothing but the header, right? It contains something called as, one of the project we are working on is called as a PRID energy, where using multiple views, right? A end user view, a producer's view, a transmitter's view, from multiple people's view, we would like to predict what is the energy that is likely to be used or that is likely to be in transit, right? Because the energy cannot be stored. The energy storage is very costly, right? That's why electric cars are very costly. If it is like petrol cars, the petrol engine is available at 2 lakhs, the battery is available at 5 lakhs, right? So storage of electricity is very costly. It is necessary for us to produce how much is required only. Anything less is shortage, anything more is not, it is loss, it is wastage. We should not develop more than what is required. How do we predict it? So that's why we call it as predictive energy, PRID energy. So navbar is one which contains the header. This is one of the components we want from Dash. The next is card with a gauge chart. Gauge chart is a fancy thing. You could have given it as a number, but if it is given as a number, people don't like it. Everybody likes to have dashboard because the visuals capture emotions. If I give numbers, only accountants will be appreciating it. Rest of the people will not appreciate it. So I had to give a dial gauge. So there are 4 dial gauges which I had to develop. Then there is a card with a trend chart. This is another card. Card is nothing but a container, right? That container contains a line chart. For that line chart, I have to provide the data, and that data comes from my database or pandas data frame or something else. It is very simple. You have to understand the flow. Once you understand the flow, if you can tell like that as a story, learning it is not difficult. When you try to memorize it, it is difficult. Don't try to memorize it. Try to understand how the story is going. If you can tell the storyline, learning it is very fast. So once we do this, we would like to have card with multiple charts. This is only one line. This is multiple lines. The actual value and the predicted value both are to be presented in a single chart. These are the 5 gadgets that we are trying to have. Along with this, there is one called as dash canvas. There must be a container which contains all these 4 gadgets and serve it from the backend. Can all of this be converted to HTML, CSS, JavaScript, and things like that, and provided without me knowing JavaScript, HTML, and things like that in depth? It is not that I'll be staying in rocks or forest. I don't want to learn anything, but I do not want to become a front-end developer. I do not want to become a back-end developer. I want to become an IoT analytics engineer or AI engineer who can do full stack. I can get the data, I can build the model, I can understand the business, I can deliver the model, I can deploy the model. So these are the 5 skills that we are expecting from AI engineer. And in this workshop, from now on, I will be getting into the coding, right? If you are ready, let me know, raise your hands so that we'll start coding. Yeah. Okay. I'll stop my presentation here. Let me get on to the coding part. Right. Now you have to start your Jupyter, right? Basically, we are looking at how can you start, right? You can come to your Jupyter. So I hope everybody started Jupyter or Colab, right? If there is any query, some of our boys, the technical assistants who are there in the workshop, you can connect with them and they will help you in setting it up. But the idea is let us run through it slowly, clearly, so that we can start experimenting by some modifications and something. Is that okay? Okay, so we'll start with what do we do now? So the first thing we would like to start is to create a new notebook. Go here, click on Python 3, right? You will get a new notebook. Yeah. Anyway, all this code will be shared with you at the end of the conference or the workshop, right? You can run it at your leisure also and digest it. That's very, very important, right? The first thing we would like to do, now we have understood the business and we would like to look at the data, right? We have sent you the data. You can look at the data. It contains 6 columns and it provides us what is the independent variable, what is the dependent variable, basically what is the attribute, what is the label, right? So we are interested in building such kind of models. I will not build very deep model. I will just touch upon how to build a model, not getting into fine-tuning the model, evaluating and all those things. We will just see how well we are building the model, right? So now I would like to import some libraries because Python is, the Dash and Pandas and scikit-learn are called as what are called as the low-code systems. You are not writing anything from scratch. We will just call the function, we will pass the data. And if you know how to call a function, how to assign the output of a function to a variable, you're done. You can start the programming. For this, before we can start any programming with Dash and Python, Pandas and things like that, it is necessary for us to import certain libraries. Let us import those libraries. And commenting is very important, right? Import libraries. So this is a comment. If you know Python, it is good. You can go ahead. If you don't know Python, for the people who don't know Python, this is a comment. This cannot be executed. The interpreter ignores this. This will not be executed. We are importing the libraries. What are the libraries that you're importing? We will import Pandas. Pandas is a library. It is called as Python data analysis library, which is called as Pandas. right? Pandas is the library for data analysis in Python. It is written in C++, and a wrapper is provided. We need not to worry about how it has been implemented and all. To drive a car, should I know how the car has been manufactured? If you know, there is nothing wrong with that, but that is not useful for driving a car. Somebody who designs a car may not be able to drive the car if he cannot, if he don't know how to drive the car. So don't worry about how it has been implemented. What APIs are available for us? API is nothing but a function available for us. So import pandas. Every time I do not want to write pandas, I would like to call it as PD. Import pandas as PD. It's a general practice. You can say instead of PD, you can say JBS. But when people read it, they say that you are self-centered, arrogant. We don't answer this. So as far as possible, when you are in a society, follow the society. Don't go against the society. If you are in the group of Python programmers, be more Pythonic, right? Don't try to be, no, I'm coming from C, I will write C. You have to treat me well. They will not. Nobody will treat you well. So follow the rules, very, very important. The next library that we would like to import is called as a NumPy. It is numerical Python. Basically, it's a matrix library like your MATLAB. Some of you might have already worked with MATLAB. So we say that MATLAB and numbers, NumPy and numbers are much better than MATLAB, right? It is free and it is performant. It can work on GPU, right? Nothing against MATLAB. Only gross we have is MATLAB is costly. I have to pay. Here I not to pay. Okay, so I have to import NumPy as NP, right? Import NumPy as NP. I am importing the numerical Python as NP, and I had to basically these two libraries are data management libraries. So let us call this as data management, right? For data management, I need PD, I need NP. Now I would like to visualize something. For this, I can go with matplotlib or I can go with 𝗕𝗁. I prefer 𝗕𝗁 for the beginners, right? Don't get into matplotlib unless you are advanced Python programmer. Go with 𝗕𝗁, right? If you're a beginner or an intermediate programmer in Python, go with 𝗕𝗁. For visualization, I would like to import 𝗕𝗁 as SNS. So I would like to import 𝗕𝗁 as SNS. Next, I would like to build the models. For that, I have to import the scikit-learn library. I do not want to import the entire scikit-learn library. I'd like to import only two models. The first of the model is a linear model. The second model and third model are non-linear models, right? In fact, if you are not able to install the ELM, right? Don't worry about it. Just go with the random forest and the linear regression, which are currently available in your Colab and your Jupyter notebooks, right? I would like to go for modeling. Modeling libraries, right? Modeling. I would like to from scikit-learn, right? So from sklearn from sklearn, there are set of linear models, right? So in set of linear model, right, I would like to import linear regression. Linear regression is a class. This is a package. So linear regression. So linear regression model or linear regression class is imported. And from sklearn ensemble import random forest regressor. So ensemble random forest regressor. So these are the two models. Let us import these two models. Now I would like to say go ahead, right? If there is an error, don't worry about it. Just you have to read the error and fix it. The few errors that may likely to come are, for example, let us say that I would like to drop this and I will enter this. It says that it cannot, because it says that it cannot import, right? It is not there, right? Now if I put this, right? It is imported, right? You can run this, right? Once you run this, your data management libraries are imported, your visualization library is imported, your modeling libraries are imported. Now we have everything, all the utensils that are required for kitchen cooking is available. Now we have to get the rice. Where is the rice? Rice is nothing but our data. So now I would like to read the data. Read the data, right? How do I read the data? Very simple. Call DF. DF stands for data frame. Data frame is nothing but your table, right? A tabular structure, a matrix, that is the data frame. But data frame is implicit symbolic for us, right? It carries no meaning. If DF is given 5, it becomes a kind of a static variable, right? It becomes a scalar, right? But when DF is given with PD read underscore CSV with where the file is. My file is in my D drive, right? Everything has to be given in double quotes or single quote. Prefer double quotes, right? Especially when you are giving the file string, try to go for double quotes, right? It is in D drive for me. You may have different drive. It is in race, right? It is in workshop, right? It is in workshop, right? And my data is in data, and the file name is ccpp.csv. I will read this data. Now my data is read. Once my data is read, I had to understand the data. What is understanding data? There are few things, a hygiene check that you have to do, right? Normally we say, no, whenever you go to a new place, try to search for, is there a hotel, right? Is there a hospital, right? Where the bus will come, where the car can be done. All these things should be thought about before even going there and before even settling there. Simply you should not go and say, I didn't know, I didn't check. No, that is not a good practice. Good practice is hygiene check. What is hygiene check in data exploration? We would like to check first few records, last few records, sample few records, right? So we call that as eyeballing the data. Eyeballing the data. How do I eyeball it? Get df.head means top few. By default, 5 records will be given to you. Now look at them. So 5 records, right? Curiously, if you see record number is 0, actually it means it is 0 indexed. Everything in Python start with 0, not with 1. So first record is designated as 0, but actually it is first record. So the variables are AT, VC, AP, RH, PE, and PR. These are the variables that are available to us, right? We get these variables. Now I would like to see what are the column names. But before that, I would like to eyeball fully. I did the head. So always you have to think, if there is a head, there must be a tail. Let us check that. Is there a tail? So is there a tail? Absolutely there is tail. Last 5 records will be given to us, right? With the same variable list, last 5 records are given to us. Now I would like to eyeball. I have seen the top few records, bottom few records. Now I would like to see in between sample, how are they looking? Are there any missing data, right? Now let us go for df sample. Sample, if we don't give, it gives 5. Now let us give sample of 10, right? It shows me 10 records, right, as sample. None of them have got any missing values. So I need not to worry about data preparation, things like that. Now I must explore this data. Are you able to do this? Were you able to see what I had done? In fact, I have used a very simple thing. I started with read CSV. So once you read it, you will see head. How many top few records? How many are there? Are there any missing values? Are there any outliers? Are there any skewed values? Are there surprising values? Are there? This is what you are looking at. So once you get this, you will look at the type. Then you will look at the sample data. Right? So everything is okay now. This is how we have to start. Don't try to take very complex problem and try to solve that. You end up giving only problems. It contains a lot of problems. It contains no, that is not the way. When you swim, you don't start swimming in the deep sea. You start in a small swimming pool. So this is a small swimming pool, right? All data is clear, everything is predictable, we know how it works and all those things. A lot of papers have been written on this. It's not a toy data. It contains around 10,000 records, right? Not 100 records, right? It's a good data. Now if you can give this, sample is given to me, right? Now I would like to see, is there any missing values? So I would like to give, in fact, you can say directory of 𝗕𝗃. What are all the methods, parameters available to me? It says that 𝗕𝗃 contains all these things. It contains AP, AT, PE, PR, RH, T, VC, and all those things. All of these are variables, right? These are the variables, and T is basically transpose. Don't mistake it for variable. Right now we are looking at, are there anything that I may be interested in? Is there a box plot? Yes, there is a box plot, right? Then there is what is called as correlation. So correlation is there in this, right? Always you can read the documentation, you can look at the direction or directive of a particular library or a object or a package which does the self-reflection and gives what it has, what methods, what variables it has, what hidden variables it has. All those things will be visible, and mostly they are intuitive, right? I would like to look at duplicates, all those things. I'm interested in 𝗔𝗚. So let us look at 𝗔𝗚 is there. Right now, if you look at it, right, 𝗔𝗚, right? 𝗔𝗚 is one thing that we are interested in. 𝗕𝗃 dot 𝗔𝗚. What I would like to do, I would like to take this as sum, right? How many are there as 𝗔𝗚, right? There is no missing value in my data. That's good. Whenever there is missing value, you must have a method to handle that. Should I drop the record? Should I drop the column? Should I impute that missing value with something else? All those things are to be checked. Now, it contains no missing values. Now, I would like to go for, can I check something with respect to the variable? So I will take that variable. A variable can be accessed. A column in the data frame can be accessed by the variable name in double quotes or single quotes. I will take the single quotes to know what are the columns that are available to me. Let us take, these are the columns that are available to me. So you just give 𝗕𝗃.columns. It tells me what are all the columns. It contains AT, VC, AP, RH, P, and PR. PR is an identifier, not useful for me. I would like to analyze these 5. How do I analyze these 5? The first thing I would like to do is draw a histogram, generate a histogram of these variables. So take 𝗕𝗃 AT, right, and say hist, right? So histogram is given by hist, and it looks like this. So it clearly says some kind of two modes are there, or 2 peaks are there. Can you see this? But we want to make this more intuitive and more smooth. This is not smooth, this is ragged, right? So in such case, I would like to go for 𝗕𝗃 AT. There is a function, or there's a package called as plot within this. It's a sub package. I would like to call it as plot density. When I plot the density, I'm getting a smooth flat, right? Which tells me there are possibly 2 peaks. This is one way of analyzing the data. Why this is needed? Because if it contains only 1 peak, it is of no interest to me. If it contains multiple peaks, it is interest to me. If it contains gap, it is interest to me. If it is skewed, it is interest to me. If it contains missing values, it is interesting to me. Normal? No, nobody is interested in normal. Like the film stars, no? We all like film stars because we are not film stars. They are outliers, right? We are very interested in them. Ourselves, we are not interested. So rather in AI, personally, I feel we must be interested in normal people, not abnormal people. We should never become abnormal, right? We should be normal people only. So once we do this, we would like to repeat the same thing for AP. Let us go with 𝗕𝗃 AP, right? Plot dot density. So I can go for density plot. So density plot, you can see, looks normal. There's nothing here, nothing much interesting, right? Let us see whether I can do this for my RH. So df RH, which is relative humidity, can I build the plot which is density, right, for this, right? So can I build this? Yes, it is also looking normal. There is not much that I can see here, right? Not much of interest. Now let us look at vacuum, right? Let us look at df vacuum, right, dot plot dot density. Quite interesting, isn't it? So it is bimodal. Actually, it is trimodal. You can say that it is 2.5 men. So it is 1 man, 2 man, 2.5 men. But for all practical purposes, we will take it as 2 men or 2 peaks, right? So these 2 peak, in fact, I'm interested in these 2 variables. That's how we try to do the exploration, univariate exploration, right? Once we do the univariate exploration, I would like to see how my PE is distributed. Dot plot dot density. How my, so it is also kind of bimodal, right? It is bimodal. For example, it looks like the peaks are high, right? This is bimodal, this is bimodal, right? Whenever the vacuum is high, the peak is also the this is also high. Whenever it is low, it is more, right? So we are interested in, okay, we got this hunch. I cannot say we verified it. Now we would like to verify, is there a relation between 2 variables? I can check with all the variables. In fact, I would like to check with all the variables first, right? Now let us look at how do we check. In fact, before going to that, we would like to look into box plot, right? Is there a way in which there is a deviation or an outlier that can be seen in the data? Now for that, we would like to go with PE, right? Box plot dot box plot. So what is the box plot? Plot box plot. Plot box plot. Plot accessor do not have. Okay, we'll come to this later. We'll see this later. Now let us get into pairs, right? How can we get SNS dot pair? So I would like to pair plot, right? I would like to get into analyzing 2 variables. I would like to get into DF. Now, if you want to access only 1 variable, it is very easy, right? It is PE or let us say AT and PE. In fact, I would like to just give it as, right, AT DF PE, right? It gives some error, and let us look at what is the error. The error says it must be an object, right? It cannot be 2 classes. It cannot be a series. Now I would like to combine this into 1, right? So I cannot give like this, but I would like to give it as another one. So if you can give like this, right? It gives me how they are connected. So now if you see, right, the distributions are very clear. So this and this are matched, this and this are matched, right? P will be high, right? So the relation between these 2 is whenever the temperature, whenever the atmospheric temperature is low, power produced is high. Whenever the atmospheric temperature is high, power produced is low, right? You ask domain team, they say yes, that is correct, right? Without asking domain team, we understood the relation. We will present this to the domain team. Similarly, we would like to look at others, right? We would like to look at DF SNS dot pair plot. Then we would like to look at, I will copy this, and instead of, I would like to put RH, I would like to put RH and see how it looks like. my RH is not giving me anything better. There is nothing. I cannot see a line. I cannot see any relationship. Though there is bimodal thing, this is normal. This has really no effect on it, but there may be some correlation for prediction, not for control. I cannot control anything, right? So I would like to put this, and okay, so let me change this. I would like to look at SNS dot pair plot, right? I would like to present, instead of AT, I would like to go for AP, right? Let us see how it looks like, right? Pressure also has no effect on anything. There is no effect with pressure. Next, I would like to go for SNS dot pair plot, right? I would like to go with vacuum VC. So I would like to go with vacuum. Now you can see that whenever the vacuum is low, power produced is high. Whenever vacuum is high, power produced is low. That's good. So there is a relation. I can use this as a predictor. If I know vacuum and temperature, my prediction will be better. Can I build a model using this? So as a next fancy thing, though I really never advocate, if you don't have time, if you feel difficult, go for SNS dot pair plot DF, right? This does the magic. It gives everything. But when the number of variable crosses 5, you can see nothing, right? It looks like some kind of dotted images. You cannot assign anything. It is better if you can go for pairwise analysis. So when you do pairwise analysis, it becomes easy for you to do. This is the pairwise one, right? Now I would like to go for identifying what is the correlation. We found this, but numerically we would like to identify how much relational strength is there between atmospheric temperature and the power produced, the vacuum and the power produced. So that can be done with what is called as correlation coefficient. You take this, you just give car function, it gives everything, right? Now I would like to use SNS dot heat plot, right, for correlation. Heat map, what is this? Maybe SNS. Let me check what is this, right? Directory SNS. SNS tells me what are the heat maps that are available. Heat map. So I had to write it as heat map. SNS dot heat map dot TF, right? Now you can see what is connected to what, right? So I do not want this PR because it is not giving me anything, right? Now I would like to change this PR. I would like to select only few of them, right? What I would like to do is I will select few, right? I would like to select AT. I would like to select AP, atmospheric pressure. I would like to select RH. I would like to select vacuum. Then I would like to select PE. I want the relation between these parameters, right? Let us get the correlation also like that. Correlation only for this, right? Currently it is giving for everything. Let us take only for this. What is the correlation? So I will get my correlation. My correlation is DF for all of this. Right now I would like to go for correlation heat map. DF is not there. Let us remove this, right? Now I will drop this. I don't need this. Let us see how my correlation looks like. So my correlation looks like this, right? It says that atmospheric temperature is 1 obviously, right? But AE is related to PE by 94%. 94% of energy that is produced can be explained by atmospheric temperature. Similarly, 86% of the energy generated can be explained by vacuum. Others can be explained with something else, right? But these are the two important factors which can be used for building a model, right? So now once we have this, we would like to go for building the models. But before building the model, let us build a baseline model, right? How do we build a baseline model? Let us look at how do we build the baseline model. So Now I would like to select X and Y. How do I select X and Y? I would like to put all the variables in the first line as X and rest as Y. So let me take that. Now my X, I would like to designate X is equal to DF, or already have that, right? I will take this, except this. These are called as attributes or independent variables. These are the independent variables. And now I would like to take Y. Okay, the reason it is not closing is I have not closed this bracket. Okay, so now my Y is equal to DF-PE. My DF-PE is my Y. So now I took X and Y. So most of the times model building is nothing but mapping input to output. So what are the inputs here? AT, AP, RH and VC are the inputs. PE is the output. Right? Now I would like to build a linear model with this. Right? The model building is very easy. The first thing is you have to instantiate a model. Right? Now call this as model LR. Right? Model LR is equal to linear regression, which we have imported earlier. Right? Take this. Now you are instantiating this. The model, the class has been instantiated. An object of that class has been created. Now I had to call a fit method of this model ID or model LR. Now I would like to say model LR dot fit. Fit requires 2 points. What is the input? What is the output? What is the input here in our case is X. What is the output is Y. When I execute this, it tells me it has built a linear regression model using X and Y. Right? Now what I would like to do, I would like to use this model to predict the Y value given this X. What I have done, I have used X and Y to learn the model. Next, I will give only X as the model to predict Y. I have Y and Y cap. Now let us call this as predictions, right? Or LR predictions. LR predictions. LR predictions is equal to model LR. Model LR. We will call a method called as predict. It is as easy as that. Instantiate the class, fit the model, use the predict function. Fit the model using the fit function or fit method, predict the values using predict function or a predict method. So here what we are passing X, right? It will predict. Now we can see what is there in LR predict. Right? LR predict contains a lot of values, around 9,500 plus values are there for prediction. Now I would like to add this to my DF as LR prediction. Right? How we do this? Just take DF. I will say LR predictions. Right? LR predictions is equal to LR prediction. So now my DF is added with additional column and I can see that with DF head. My DF head is created. Right? My DF head is created here. So LR prediction is done. I have predicted. I have added it. Right? Now I would like to go for building a random forest model. So how can I build a random forest model? Same thing, right? RF model. Right? DF head. So I had to change this to code and run this. Then I will get this. LR prediction is known to me. Now I would like to build, right? Build random forest model. Right? Build the random forest model. Right? How do I build the model? So my RF, is it LR prediction or model LR? So it is model LR. Now let us call this as model RF. Model RF is equal to random forest regressor. Right? So random forest regressor requires some parameters to be added. Now let us look at what exactly are these random forest regression parameters. So the first of this is, what is the maximum depth? How far you would like to build this? The maximum depth is, let us set it as max depth DPTH. Maximum depth, let us say 5, right? Now I would like to build, in fact you can start with random state as 0, because that is very important. You have to rattle the data, right? Random state, right, is equal to 0. For the time being, you assume these are the parameters that are to be set. So once you get into the depth of building the models, you can understand what is meant by all these things, why you have to set this, why this becomes a hyperparameter, how do you tune all these things. That's one thing that we do later, right? Now we build this. I would like to fit the model underscore RF dot fit x comma y. Same data has been used and we are building the model. The model has been built, right? Now I would like to go for RF predictions is equal to model RF dot predict x, right? Now you can see how the data looks like for RF prediction. RF prediction data looks like this. Now you remember, we would like to add this prediction, RF prediction, to my data frame, to my table, right? Now I will say that df RF prediction is equal to RF RF underscore prid. So now we got it. Let us look at 𝗕𝗃, right? So now my linear regression is predicting 477. My RF prediction is predicting 481, which is near. Actual value is 480.48. This is much near to that, right? In some cases LR is near, in some cases RF is near. Now we would like to find what is the error between this actual and predicted. Now get that, let's get that. df LR AE is absolute error. So absolute error is equal to absolute minus df PE. I will take df PE minus, right, df LR prid, LR underscore prid. If I use this, right, similarly I would like to I will compute LR AE. Similarly I would like to compute my RF AE. So my RF AE I would like to predict here, or I would like to add here. RF AE is equal to this. Now ABD, it must be ABS. So it must be ABS, right? So we got everything now. Now 𝗕𝗃, you can see 𝗕𝗃, you can see that we got the predictions, right? We got the predictions and everything running up and running. Okay, good. We have all those things. Now we would like to see which of the error is good, and that is called as MAP-E, right? MAP-E LR is equal to df LR AE, LR underscore AE, right, dot mean. So I would like to get the average error of LR. So I would like to get the average error of LR. Similarly, MAP-E underscore RF is equal to df LR RF underscore RF dot mean. What is missing? LR RF. Sorry, RF RF underscore AE, right? We got them. Now we would like to print both of them. Print linear regression error is equal to 𝗲𝗃 LR. Right? Actually, it is not 𝗲𝗃. 𝗲𝗃 comes later. We will see that later. Okay. So print 𝗲𝗃 random forest error is equal to 𝗲𝗃 RF. Right? Now we can see, right? So my linear regression is 3.62. My random forest is 3.16. Which is better? Random forest is better because it is at least 15% better than linear regression. Why? The explanation can be given here. If you see this, right? If you see this, this is non-linear. Though there is a line, there is some non-linearity. That's why here also there is some non-linearity, right? It is not completely line. So that can be explained better by a non-linear model. Though some of the papers which are already using deep learning and all those things, still I prefer a non-linear model which is giving much better result. Right? So when we look at this, this is good, right? We got all these things. Now I would like to use only my random forest model, right? And store that. So now my original data, I had AT, VC, AP, RH and PE. Now I would like to retain RF prediction so that I can show it in my dashboard, right? I would like to take that. I would like to take columns is equal to AT, comma AP, comma RH, comma VC, comma VC, comma PE, comma RF grid, RF grid, right? These are the columns that I would like to have, and I will take this, and I would like to take DF2 is equal to DF of columns. So this is the new DF2 I have created, DF2.head, right? Only these will be taken, right? What are the columns which are measured? These are the sensor measurements that are coming from IoT devices. This is the computed measure. This is the predicted measure, right? Now we had the data which is coming to us like this. The data was coming to us like this, which contains 4 variables, right? I mean 5 variables which are computed or something like that with one identifier. Now we would like to add this, right? So this is my new data set, right, which contains, along with this we need PR, right? This will be PR also because that is the identifier. So now if you see for every column, first our what was AT, AP, RH, VC, and what is the PE and what is the predicted value. All these things have been taken, and this becomes input to my dashboard. Yeah. So if you have followed this through, what we have done is we read the data from historian. We read the data here. We read the data here from the historian, and we built the model. We checked all those things, and we used the model during the runtime in real time, right? Only this model will be used. Only this function is used. We will not be using anything else. We'll be using only predict. Only this function is used, right? Most of the times, right? In real time, we'll be using only this function. Pass the data and get the prediction, right? So we will predict. I will get all the data, right, and predict what is the energy that we produce. This is the real-time implementation, which I'm parking for some time. Maybe in next workshop, when you are participating, possibly we will try to get into how do we deploy real-time scoring systems. Now this time we are interested in how do we develop an AI model, how do we develop a app based on that model's outputs, right? Subsequently, how do we make it real-time? How do we include additional variables? How do we get insights directly going to the somebody's mobile? All those things are bells and whistles. Now this is the core. Understand the core. Now, once you get this, you have built the model and your data is again improved and the prediction is added here. This prediction is what we are showing in our dashboard. Yeah, so this completes the first half of our application development. We got the model, we built the model, we analyzed the data, we evaluate the model, we selected the model, we use that model for prediction and predicted all the data and updated it. And this data is available for us for presentation. Now we would like to go back and check what exactly we were supposed to do. Now, if you look at it, I had to develop my application like this. So I had to get my dash canvas. I had to get my nav bar. I must get card. I must get card with multiple charts. I must get card with trend chart. So once I get this, put all of them, pack them well, run the application. This exactly is what we do in the second half of the workshop, right? If there are any questions, if they have posed it, and let me take one or two questions. Nikesh, if there are any questions, let me know.
Not much, Prof. I think all of them are there. If there are questions, please let us know. Nothing related to the code. We have generic questions.
Okay. No problem. We can take generic questions later. Maybe we'll go ahead with the application itself. Right? Sure. Writing this application may take some time. That's why I would like to go with the code itself. Okay. So this is the application that we are trying to develop. This is how the application looks like, right? We have all the four, sensors that have been giving the data, the average value of those, variables, or we call that as tags, right? In IoT terminology, it is called as tag. So tag average value is this, and we will measure this and put it as gauge charts. Once we have the gauge charts, gauge chart will give me average. It will not tell me anything about how is the trend, how it is moving in real time, what is happening to that variable, that tag, and that will be given as line charts. We will give that as line charts, right? Okay, we give that as line chart. And what about the prediction? Then we will give this line chart will be for measured variables, not the computed variable. The prediction chart is for the computed. This is measured and this is computed, this is predicted. Now we would like to build all these things in our app, right? So now let us look into how do we do this. The first thing that we would like to do is, I will open up my application. Let me take this step by step. Okay, normally we try to write who is the author, when it is been done, all those things, right? Where it is been tested, all those things have to be written. Simply don't dump the code. That is not a good practice, right? Between friends, just we are checking and getting the skill, it is okay. But when you are trying to present something, comment it well with the context, with the author, with the known bugs. All those things are to be commented in the application. So once we do this, like we are looking at data management libraries. We would like to import the data management libraries. What are the data management libraries we are importing? Pandas as PD, NumPy as NP. We import these two. Once we import these two, we need the libraries for the real-time, kind of web cards, right? These are web gadgets or HTML gadgets which contain JavaScript and CSS and all those things, which can be pushed into my application. I do not want to write HTML. I do not want to write anything. Though partially I will write what kind of, you can call it as formatting or styling, right? Cascade styling, but I do not want to call it as CSS. I would like to just call it as styling. You can give styling, but beyond that, we don't need to know anything, right? For a simple application like this, no need for learning anything. Only Python is more than sufficient, right? Actually, you can use this as a template for developing any other application. Use it and try to see how it works, right? We need Plotly Express, right? You can use Plotly, but Plotly is like opening Pandora's box. As far as possible, try to go with Express for first 1 year, right? After 1 year, you can go for using Plotly. You can become Plotly developer. That's not the idea, right? Today it may be Plotly, tomorrow it may be something else. I do not want to become specialist in that. I want to become specialist in IoT analytics. not in this technology, that technology and all. That I will learn just in time. Now the current trend is Python, right? For IoT analytics and all those things. Subsequently, next 5 years, it may be Julia. Learn that. Your principles will not change. The technology is changing, but the actual work is not changing. Always get principles right. Rest of the things will fall in place. Okay. Then, because we are running this in Jupyter, we need Jupyter Dash has to be imported. And there are certain core components of Dash we would like to import. Right? First of this is core components. It can be canvas, it can be application, it can be kind of routing and all those things. They're all core components. Then we need some bootstrap components. Actually, bootstrap is a library which combines CSS, HTML, and JavaScript. Right? It embeds all those things in a kind of it wraps everything and it exposes some APIs. If you call button, a bootstrap button is different from HTML button, because it's already styled, it works across all the browsers, right? Any problem that you have to handle independently has been handled by best of the developers. Use bootstrap components. So DBC is one such component. If you go to the Plotly Dash documentation, you get details of everything we are doing here. Any doubt, refer to the original documentation, right? My suggestion is always that rather than using any blog, and blogs are good, there is nothing wrong with it. Actually, you have to write a blog. After you do this, you have to develop a blog and write it. That shows how good you are in communicating, how people appreciate what you have done. That may be a job opener for you. That's good, but don't implement that with blogs. Try to go for documentation. Right? Next is DAQ. Basically, this requires for queuing and other things. We need this. Then there is HTML components. Right now, HTML components like the title, the paragraph, all those things we need HTML components. Without knowing HTML, we have to know that this is H1 heading, this is a paragraph, but I not have to have the angle brackets, starting angle brackets, ending angle brackets, then trying to give all the styles. Not necessary. We can just give it away. Yeah, I will explore. Import all these libraries. Let me import this. I will import these libraries. Right. Once I import these libraries, look at this data. I'm reading this data. Now, what I would like to do, as soon as I did this, right? So what I'm trying to do is, I'm trying to get, I have written it here, right? My df2 is to be written somewhere. df2, right? Dot to CSV, right? I would like to write it as D, right? Race workshop CCPP scored second, because already I had done scoring. I would like to keep it as second CSV. Now this will be available. This has been written, and if you go there, you can see all of that, right? In D, in race, in workshop, right? In data, right? Okay. It is in workshop only, right? CCTP scored second. Now this is how it has been stored, right? It attaches one index. We have to drop this index when we read this. So it contains PR, AT, AP, RH, VC, PE, RF prediction. All this has been written. This is how we would like to do. Though this is a very rough method of predicting and then connecting it, there are better methods which are called as the streaming methods, which we can do when we get into a short-term course or things like that, right? In a detailed workshop, we can do all those things. For the time being, it's a quick fix. We are doing this. We got this data. Now we have to read this data, right? We are reading this data, and I would like to compute a few of them. In fact, these are not necessary. I would like to compute AT mean, atmospheric temperature mean, as mean, vacuum mean, because I would like to present those mean for this screen. For this screen, I have to compute the mean values. I have to compute the mean values for this screen. And we have seen that the atmospheric temperature is between 0 and 45, and this becomes my minimum, this becomes my maximum. This is the current value. and this comes as whenever you compute, it will be coming as the float, right, which may be a 64-bit kind of thing, which contains high precision. We don't need it. We have to just format it into only 2. That is what we are doing here, right? So taking that clue, we are computing. Why we are computing it? What is that we are doing? We are computing mean. Why we are computing it? Because we have to put it here. How do we do this? We do this like this. We do this with calling the mean function of the column of the data frame. That's what we have done. Now, if you can understand what, why, how, all that we has been answered. What are we doing? We want to present a gauge with mean value. That is what. Or why? Because mean value is very important for us to know, right? How do you do it? By calling the mean function or a mean method of the data frame with the selected attribute. So once we do this, we will do it for vacuum, we do it for relative humidity, we do it for atmospheric pressure. So we do all those things. Then we would like to print what are all the mean values. It says that the mean value is 31, 37, 19, 80 max. It's all maximum, minimum, and so let me put 80 mean, 19. Then I would like to go for AP mean. Then I would like to go for RH mean. Then I would like to go to VC mean. Right? 19, 10, 13, 73, 54, all is there. Right? We got all of them. Now we would like to look at, is there a possibility for us to embed all these things into a gauge? For that, what we have done is, in fact, you can do this independently, but we created a function, our own function, right, as get gauge chart. What are the things I would like to pass? I would like to pass title. I would like to pass x-axis. What should be written in x-axis, right? What is the value? What is the maximum R and what is the minimum R, right? Now, for this gauge chart, I have to compute when this becomes yellow, when this becomes red. So from here to here, from here to here, here to here, I would like to compute how exactly it looks like. So yellow, the green will be from 0 to 15. This will be from 15 to 30. This will be from 30 to 45. So how do we do that is one thing that we would like to see, and we would like to pass the value. So I will get this and compute this, right? Once I compute this, I would like to, in fact, you have seen my values are 19.65123118, blah, blah, blah. Big, too big. So what I try to do, I try to add that condensate into only 2 decimal places with float formatting. I do the float formatting, reduce that value, right? Now I computed all the things that are required. Now what I have to return? I have to return a div, right? Div basically is a division or a part of code. That div will contain a card. Card is a container. So div contains the card, and card contains the card body. The card body contains the gauge chart. So you can go and check the gauge chart. Gauge chart inputs are given, and I am adding gauge chart into the card body. And card body also, the card also contains what is the text at the bottom or at the top, right? You can set that. By default it is at the top. I want the text to be something. I'm giving this as the text. Text is x-axis. What is x-axis? I'm giving x-axis, right? It can be AT, AP, RH, right? All those things. And the style is align it to center. Don't put it into the ends. So this returns for every variable I'm passing, the minimum value, maximum value, and mean value I'm passing. It gives the gauge chart and sends the gauge back to me. I'm taking that gauge chart. So I execute this. Function is executed. Now I would like to build a line chart similar to the gauge chart. I would like to give what should go in x-axis. Y-axis is very clear. The period, the time period is the x-axis. What goes in y-axis? Value of atmospheric temperature, relative humidity, vacuum, all those things is what goes into y-axis, right? I'm not showing too many because I wanted to show very few, right? About 9,550 and above, maybe about 14, 15 records will be shown, but you can set this, right? Your y-axis is this, your x-axis is PR, right? Your y-axis name is what you're sending, right? And the background is dark background. In fact, you can ask, I would like to go bright. No, in most of the IoT applications, the theme is always dark for two reasons. One, it consumes less energy because most of the pixels are black. That's the first reason. The second reason is the strain on eye is less if it is dark. So these are the two reasons why most of the IoT applications are going with the dark background. Though current applications will come with all colors, any jazzy all color kind of thing is stress on eyes. We have to reduce that. That's why we use dark. So that will return a trend chart. So this is another function we have written. A trend chart will be done. Then I had to build a predictive chart. The difference between the trend chart and the predictive chart is predictive chart contains actual value of the energy produced and the predicted value of the energy produced. Where I'm having that PE is actual energy that is produced, prediction RF. So in this case, prediction RF, yes, that's okay, is the power that is generated and predicted, right? This is the predicted power. So I do this also. This is my prediction. Now I built all these three, right? I built a function. You pass some values, it will give me this figure, this figure, this figure. All of them is called as a factory pattern. So if you look at this, function, right? This is a factory pattern. When you go to design patterns, all these things will be asked. Have you done factory pattern? Yes, absolutely. You did factory pattern if you have done this. Give me anything, as long as it is a black car, I will paint any car. That's a factory. What you do in factory, you collect it in mass. Just give me specifications, I will develop that. So you are developing a factory pattern here. You got this ready, you got the factory pattern also, but this is a singleton pattern. Singleton pattern is where you are hard coding most of the things. You do not want things to go, right? It is not a factory, it is singleton, right? So I'm taking this. There are three patterns that you're learning, right? One is a factory pattern, another is a singleton pattern, the third is MEC pattern. MEC pattern is the application itself. I will not get deep into MEC. The model is basically the pandas data frame that we have selected, right? The view, the HTML page that is sent to the browser is the view. The controller is, this is what we are writing as the controller. These are the controllers. This is the MEC pattern. You know what exactly is the factory pattern. You know what is a singleton pattern. So we learned three patterns in this particular application, right? That's one of my expectations. When somebody comes and writes everything but cannot explain what that is, it means that he is not educated. He's skilled, but he's not educated. So I want you to learn the design patterns also along with your data science, your analytics, your AI. That's very much essential. I may not know, but people will ask. People like me will always ask, are you educated and skilled, or are you just skilled? There are three classes, right? Educated, they know everything, how to do all those things, they will explain. When I ask them to do, they cannot do. The other group, they are skilled, they will do, somehow they will do, right? Both groups are dangerous. You must have educated and skilled group. And our expectation is that you should become educated and skilled, not just skilled or not just educated. That's not good, right? We will write the difference between gauge chart and the predictive chart is, predictive chart is a singleton pattern, gauge chart and the trend chart are the factory patterns. Once we do this, after doing all these things, we will go for nav bar. The navigation bar is basically this part. This part is the navigation bar. This part is the navigation bar, right? Print energy, everything is predictive, is the navigation bar. So how do you do the navigation bar? You try to create a row. You will create a row, right? Within that row, the columns will be added, right? The column will be nav bar and the name of that will be predictive energy. And I'm adding one more, everything is possible. Rest of the things you can keep as it is until you become very familiar. You will not have to worry too much about everything. You can copy this and make some changes here and add them. So I'm creating nav bar also. Once I create the nav bar also, then I'll be laying out what is called as a layout. When it comes to Dash application, you have to understand only three things: data access, layout, callback. Data access already we have done. Layout we are discussing. Callbacks probably is bit advanced. I will not touch upon because that will be very helpful for building everything in real time. You can access within milliseconds. You can send it here and it will be shown here, right? It requires some kind of deep dive. That's why I parked it, because anything that is tough, even I don't learn if it is tough. I don't know about you. If people are there, only if it is tough they will learn. But for me, if it is not simple, I don't learn. If it is not stupid, I don't learn. If it is not useful, I don't learn. Right? So callback is a little bit difficult. I would like to keep it for some later sessions. Now, I'm laying out my layout. So what is that I'm trying to do? I'm trying to write the HTML driver. Then I'm trying to add in the card body, I'm adding to add atmospheric temperature gauge, relative humidity gauge, system vacuum gauge, atmospheric pressure gauge. I'm adding 4 columns, right? Whenever you look at the Bootstrap is based on 12 columns. So Bootstrap divides the entire screen into 12 columns. Now what I'm telling, you take 3 columns, you take 3 columns, you take 3 columns, you take 3 columns. They are taking 3 columns each. Every gauge will take 3 columns each, and it is what we call as responsive. If it is reduces, it reduces. If it increases, it increases. I not have to handle anything through HTML, React, and all those things. I will do everything through Python, right? So this you can always copy, because there is nothing new that I've added here. Whatever the documentation says, we are doing according to that, right? So what are the things that should be packed into the container called div? So this is a div container for the entire layout. What are the contents of that container? It contains a gauge chart in one row. That is, this row itself is a container. I'm adding 3-4 columns here. Then I'm adding one more row which contains the trend charts, 4 trend charts, right? I'm just making it as 3 into 3 into 3 into 3, right? 4 charts which are 3 into 4. So 12 columns are taken. Temperature, pressure, humidity, and vacuum will be shown there, right? All the alignments will be at the center. So that is the second line. The third line is what we are looking at, right? Is basically draw prediction. Draw prediction, I want to take all the 12 columns. So all the 12 columns will be taken and it will be done. Now our layout has been done. After the layout has been done, now I would like to run this. Right, when I run this, right, I'll get error because already I was running something else. So then it gives me everything is in 80/80. So let me stop all of them. So it's all in 80/50. Now I would like to stop this because it's already occupied. I'm running another server that is occupied. I will stop this. Right now I'll start this. I will run only one part. So now once I run this, it will run in 80/50 by default, and I can change that to any other port. Now when it is running, we would like to see that nothing is running and it gives me the default port. Still it is giving some error. Port is equal to 80/80. Yeah, now it is running, right? So if I go there, it gives me the complete picture of what we wanted. So this is the application we wanted to develop and give it to the end users. So I can put a lot of bells and whistles. I can make sure that this will be updated every minute, or it can be updated whenever they want. If they refresh, automatically they will get all of that. In fact, as of now, we are suggesting you refresh. Subsequently, we can develop the entire application with real time without any manual intervention. That is what we will be doing in our courses, right? Especially the Certified Industrial Data Scientist course, where we'll be teaching how to do modeling, how to build use cases, how to use big data, how to do these presentations and write papers. This is what we are trying to do, right? So this is a first step for you. In this first step, if you appreciate, yes, we are interested, certainly we are here to help you. Please feel free at any point of time, right? You can connect with our program office, you can connect with our teaching assistants, and we are happy to help you, right? This is the whole application which will be useful. In fact, this application we are implementing, right? I've just shown the tip of the iceberg of the application, how it is running, what we have developed, what we have done, right? Though we are using around 200 variables, I have shown only 4 variables because this is the paper which is shared with you. It talks about the real-time modeling using random forests, right? That's what we have done, right? With this, I would like to conclude the session, right? Any questions, please feel free. I would like to thank all the people who helped me. They have provided all the slides, XYZ and all those things. And to you people who patiently listening to this, and possibly I assume you would like to make your career out of the industrial data scientist or artificial engineer. Thank you very much.
Thank you so much, Dr. Simha. And thank you everyone for joining. Am I audible?
Yeah, you're audible, Professor.
Okay. Yes, so a few questions. Yeah, let us take a few questions. We know that we haven't provided you a place where you could unmute and speak. That is because we wanted to keep up the time. But we are getting good response in the chat. So one of the questions by 𝗲 is that, is it real-time application? So I would read out the questions entirely. That computational workload to implement this model, fitting and prediction seems to be very high. And today there are developments in specialized CPUs and GPUs that have been specially customized to support the calculations needed. So wondering whether this can be done in hardware for real-time application.
It can be done, but actually that is not a good practice because the cost of producing such a kind of hardware and the demand for that hardware is very less. Cost is very high. It won't make any economic sense. Still, it can be done as a research prototype, but I'm not in favor of developing hardware solutions for these type of things. Coming to the computation and other things, there is what is called as a batch layer and a fast layer. All models will be built in the batch layer. The runtime is only the prediction component, so that doesn't require hardware. It requires ordinary hardware. It doesn't require GPU or tensors. It is not needed. TPU, GPU is not needed. So it depends on which school of thought we belong to. If you are coming from the instrumentation, hardware and things like that, it makes sense. But we are coming from software background. We always feel software is the solution, not the hardware. Both are possible. Both thought processes are possible. But I am biased. I prefer software solution.
Yeah, I think 𝗲 has again another question, or somebody else. I think 1 second, Prof. Yeah, somebody from AML is asking, signal processing background. This includes real-time implementations of some of the ideas on IoT hardware based on open source processor architecture like RISC-V, RISC_5. We are not sure whether this can be applied there.
Whether it is a RISC processor or CISC processor, these are all split-second decisions or possibly tactical decisions. Only for split-second decisions where something has to be shut down because of the safety reasons, RISC processor makes sense. For things like it is likely to happen in 1 hour, my reaction time is only 1 minute. I'm giving 1 hour in advance, and every minute I'm doing. When reaction time is huge, you don't need advanced processors. But for something which is machine-to-machine control, yes, RISC processor makes sense. This is mostly human control, right? We are giving the feedback to human. If I give in millisecond, he will not do anything. He will become helpless kind of thing. He watches the power plant is getting burned, but he cannot do. But if it is predicted well in advance, he can shut down the plant. So that is the difference. If it is MTM, go ahead. That is the way.
Yeah, if we one question from Vijay-Lakshmi, that at the beginning you mentioned about knowledge-based approach for AI. How can we practice that?
In fact, in RACE we are developing fuzzy logic based because fuzzy logic is knowledge based, right? Anything that goes with logic, whether it's a proportional logic, Bayesian logic, or fuzzy logic, you try to extract how humans think in terms of if-then rules or the graphs or their perceptions about something. That will be captured and we implement the system as a rule-based system, right? In fact, if we are developing hardware, rule-based systems are better ones because we can go for flashing and I can write using EEPROM anything that is needed. Instead of going for a 1 billion parameter neural network, I would like to go for 500 rule-based fuzzy network or a Bayesian network. That is much easier. So knowledge-based thing, we would like to explicitly extract the expert knowledge and try to mimic him at least 50 to 80%. We can do that using the rule-based systems.
There's one more question by Mohammed Sajid. What do you suggest for a beginner without any programming background in management role?
Python.
Yeah.
Just get into Python. If you know how to calculate using a calculator, you can use Python. So it just requires a good mentor and easy content so that it is not overwhelming. So don't learn anything which is advanced. You need not to become web developer using Python. You should know how to develop predictive models and application using Python. If that knowledge can be extracted, I don't think you need to worry about it. In fact, the currency of this generation should be, computability. Do you know coding? Do you know computability? That will be the currency for the future. It doesn't matter you're a dancer, you're somebody else, doesn't matter. Do you know basic computing? Yes, absolutely. Everybody knows basic computing because most of the computing requires only a high school math up to 10th standard, what we have studied, not this generation also.
Okay, few more questions which are more generic in nature. If you have any questions, please post immediately. One from Kalyan says that, is there any platform to dump the code? If he is from VLSI background, is there a platform where they can dump this code and get this work?
I'm not sure what he meant. If actually code being shared with them, yes, absolutely we will share it, right? We'll be using Git, right? We can share that. That is possible. If he meant, can it be put onto a chip? We are not good. Probably, I don't know how exactly we can develop that, but certainly it is possible. It's basically making all this code as your counters. How do you do that? Probably you may be a better person than me telling whether it can be done.
Okay, one generic question that what is the base for AI? Which are the fields that we must focus on?
That depends. In fact, AI is like politician. We keep no field untouched. Any field is okay for us. Starting from atomic science to zoology, every field is okay. Depending on what is your background, you start with your background and try to do something in that if possible. Otherwise, get into fintech, which is easy.
Yes. Okay, Dr. Rashmi, are there any questions more?
No questions. Generic announcement for all the audience. You will be getting code. We will be sharing the code and also we'll give access to the recording of the session because many of you have asked the same question. Another is you will also get certificate. Thank you.
So before we wind up and thank Dr. Simha for an excellent session, let us take a minute to talk about the organizers of this workshop. We are REVA University, as you are aware. Some of you are from the university. We have 15,000 plus students and a beautiful campus towards North Bangalore, and have about 80 or 100 plus courses around UG to PG to PhD programs. And the department which hosts the workshop is REVA Academy for Corporate Excellence. Nikesh, next slide.
Oh, sorry, I'm You can
Okay.
present it.
Okay.
I think I have to stop presentation.
Yeah, Nikesh, yeah, this is correct. So this is called REVA Academy for Corporate Excellence. We have a series of programs for working professionals in data science, artificial intelligence, cybersecurity, cloud technologies, and techno-functional leadership. And our programs are masters, as well as we do consulting projects and research and innovative projects around these focused areas. Nikesh? Our ecosystem consists of 50 plus senior industry leaders as trainers and mentors. Dr. Simha leads, is the chief mentor of artificial intelligence practices in REVA Academy for Corporate Excellence, REVA University. We have along with him another set of very illustrious industry leaders who are leading these programs. We have designed 300 plus courses for companies based on customized requirements as well as working professionals. We have a very, very thriving ecosystems of researchers and hiring partners. We have a very vibrant YouTube channel. So please check REVA Academy for Corporate Excellence for getting more details. And our participants profile, they come from 10 plus years of average experience. And those who are students and who are attending this session, we would request you to share about REVA Academy for Corporate Excellence to your friends who are in different companies, and look at some of the programs which we do. We have a very, very strong knowledge partnership. We are associated or the authorized training partners for EC Council. We have partnered with AWS Academy, Microsoft Azure, and 10 plus other senior industry companies which are leaders in this space. Some of the master's programs which we run for working professionals are these. All the programs are top ranked programs. One is in business analytics. Somebody was asking about how to get into management role with technical understanding. These programs are very, very, very interesting and career transformative. We have an MTech program in artificial intelligence. We have an MTech program for cybersecurity, and also another one in cloud architecture and security. A series of short-term programs also we run, which are in these emerging technology space. And we train various marquee organizations, which include some of the automobile giants and ITS giants. We have, we do multiple projects as well. We have a series of product and project development for various companies. And what you get in REVA Academy for Corporate Excellence is that ecosystem where you will get the best of the mentorship, industry mentorship, best of live projects, and best of the state-of-the-art algorithms and applications for business solutions. So we would request all of you to look at REVA Academy for Corporate Excellence website or YouTube channel, connect with us, and then get the best out of our programs. Thank you so much for watching. As Dr. Rashmi mentioned, that we will send you a Git link with the code. We would request you to use your own data and let us know how your learning experience has been. And you are welcome to come to our campus and look at our infrastructure, state-of-the-art laboratories, meet Dr. Simha in person, and all of us. We would love to host you at the campus, and new workshops and very, very interesting short-term programs are also being live. We would be sending you all those informations. So spread the good word and keep learning and happy learning. Thank you, everyone. Thank you, Dr. Simha.
Thank you very much.